Alright, so section 14.3, we're still talking about geometric sequences, but now there's something, we have a new name for them basically, and they're called exponential functions. So they're the exact same thing, they represent the same things, but in this case we're talking about an exponential function. Okay? So what are they basically, and how do we graph them? How do we represent them? And there's going to be a couple different ways that we represent and graph them. So right here we have a geometric sequence. Okay, so what we learned before is that we can identify the ratio, which in this case is we're multiplying by 2, right? Or we could do 4 divided by 2, which is 2. Our ratio is 2. That's what we're multiplying by each time. Right, so if we wanted to write an equation, we should also know how to do that from yesterday. We would get f of n equals, the first term is 2, times 2 to the n minus 1. That's our equation. Right, we learned that yesterday. That's how we could write the equation. Perfect. Okay? Down here, this is the second one we're going to work with. This is also a geometric sequence. And our ratio, we could do 6 over 18, or it's just 1 over 3 when we simplify it. Basically means we're dividing by 3 each time. Okay? And our equation would be f of n equals, first term is 18 times 1 over 3, or divided by 3, to the n minus 1 power. We learned how to do those yesterday. So to represent these, we can represent them in a couple different ways. The first way, well, that's right here, right? First way is just as a geometric sequence. There we go, we represented it. Okay? Another way that we can represent it is as a table, right? And a table, basically, just as we've seen tables for functions. So we have an input, which is in this case going to be our n. We'll call it our n, and our f of n. Just like an xy table, we have our inputs in our n, outputs in our f of n. So we have